Okay, now talking about the topic of span. Now example 5. Give an example of a set of vectors that span Rn. So we just have to give some examples. So a set of vectors that span Rn. Okay, that means a set of vectors which will have n components. So in this case, one of the example we can have some vectors u1, which is something like this. Start from 1 and then 0, 0, and then up to 0 for n terms. Vector u2 can be 0, then 1, and then 0, and then up to n terms are 0. So that means every term is 0 except the ith term. Okay, so u2, and then the second term will be 1. All other terms will be 0, and then so on. So un. So the last term will be 1, and then all other terms will be 0. Okay, so all of these are like n by 1 vectors, n components. So these are the vectors which span Rn. So if, for example, if you add all these vectors together, so we will get a vector, okay, which will be in Rn. Okay, so for example, if we add this, and then even if we multiply with some scalar value these vectors, so we will still get a vector which will be a n component vector in that will be in the span of Rn. Okay, next example is example 6. In this case, if we have 3 vectors u1, 1 to -3, u2, 0, h1, and u3 is -3 to 1, -3 to 1. So what we have to do is we have to find the value of h such that these u1, u2, u3 vectors span R3. Okay, so find h. Okay, find h so that the set of vectors u1, u2, and u3 span R3. That means a set of vectors having 3 components. Okay, set of all vectors. So as usual, what we will do, we can take these 3 components of the vectors 1, 2, -3, and 0, h1, and -3, 2, 1. Yes, there, and then we can try to make this system into the echelon form. Okay, so in this case, our first row operation will be -2 r1 plus r2. That will be r2. The second row operation will be 3 r1 plus R3, that will be R3. So in this case it will be 1 0 minus 3, and then it will be 0 H, and then it will be 6 plus 2 8, and then what I will have is 3, so that will be 0, and then it will be 1, and then it will be minus 9 plus 1 is 8. Okay, so further we can make this as 0. So in this case our row operation will be h times minus h times r2 plus r3 will be equal to will result into the new row r3. So it will be 1 0 minus 3 0 h 8, and then it will be 0, and then it will be sorry, it should be, or the row operation should be 1 over h. 1 over h. Minus 1 over h. Okay, so when h will be multiplied by minus 1 over h, so this will be minus 1. So minus 1 plus 1, that will be 0. So now in this case it will be minus 8 over h, and then it will be plus 8. So minus 8 over h plus 8. So in this case minus 8 over h plus 8 this term will determine the value of h. So in this case over here we should have minus 8, because 3 times r was minus 9, minus 9 plus 1 is minus 8. So we can, so now we can focus on this value. Okay, so for example, if we say that if u1, u2 and u3 are not in span, okay, if u1 u2 and u3 are not, okay, not in span, then what is going to happen? Then what is then this value should be 0, okay, over here. So minus 8 over h minus 8 is equal to 0. So from here what we get is minus 8 over h is equal to 8, or minus 1 over h is equal to 1, or we get h is equal to minus 1. So our answer is, for any value of h not equal to 1 minus 1, okay, not equal to minus 1, u1 u2 u3 will span R3. Okay, this is the answer. So we have found the answer by looking at in the opposite sense. Okay, we first suppose that this should be equal to 0, because when this will be equal to 0, we will get 0 is equal to some value. So for example, if we have taken some coefficients for the span like a, b, c as the component of the augmented matrix, so we should have some this type of condition or not having in span. But if they are into span, then h should not be equal to -1. So any value of h which is not equal to -1, that will be the that will give us the answer that u2 and u3 will span R3. Okay, next we have example 7. Okay, example 7. So suppose we have this system of equations, 2x1 plus 3x2 plus minus 5x2 minus 5x4 x4 is equal to -1. 4x1 plus 7x3 plus x4 is equal to 4. 3x2 minus x3 plus 2x4 is equal to 0. So write this system of equation, write it in the form of ax is equal to b. So in this case, if we want to write it in the form of ax is equal to b, so A will be a matrix of coefficients. So what will be the coefficients? So since in this case we have x1, x2, x3, x4, 4 variables, so therefore it will be a 4 by 4 matrix. So it should be 2, 3, and x3 is missing, so it should be 0, then -5. For the second one, it will be 4, x2 was missing, 0, 7, 1, and for the third one it will be x1 was missing, 0, 3, -1, and then 2. So it will be so since there was no fourth equation, so it will be a 3 by 4 matrix, whereas x will be equal to x1 plus x2, it will be a vector, column vector, x3 and x4, and b will be the coefficients, so -1, 4, 0. So these multiplication, although we have not formally studied the matrix algebra, but these multiplications are valid because A has 4 columns and X has 4 rows, so A can be multiplied by X, and that of course we will see later on as well. So therefore Ax is equal to B will exist. Okay, so we will continue some more examples in next video clip.